Hello everyone. In the series of 805 interfacing, in the last session we have seen that interfacing LCD with the 805 microcontroller. In that session, we have sent the data in the 8-bit format. Now today, let us see how to send the data by using only 4-bit 4 data lines. Usually, LCD consists of 8 data lines. You know that. So in the last session, we have used complete 8 data lines for data transmission. Suppose when you're interfacing more than like a multiple inputs, multiple outputs, then maybe the existing IO pins are not enough. At that time, for the efficient use of IO pins, we can take 4-bit LCD interfacing. In the 4-bit LCD interfacing, the concept is already we have seen that in the last session, which are the pin description of LCD module. I will add link in the description about 8-bit LCD module. You can refer that. Okay. So for the LCD initialization, we should initialize LCD module by sending few commands. See that here this is the command is used to configure or initialize LCD in a 4-bit mode, and 06 command is used for the display on increase the cursor position, and a 0c command is for display on cursor off. 80 command to display string from first row first column. In case if you mention 81, it will display from first row second column. Likewise, we can target the box, and 01 command is used to clear existing data, right? Now let me explain the coding part. So the major important thing is, suppose if I am sending S character, LCD will accept or will take equivalent ASCII values. Suppose just example, if S ASCII value is the 45, then how we are sending data means, first we are trying to send higher nibble. First send higher nibble data using D4 to D7 data lines. After sending higher nibble, later we have to send lower nibble. Before sending lower nibble, we have to bring lower nibble data to the higher nibble. In that context, you are rotating character rotate character to the left for 4 times, so that in our example S equals to 45, then after rotating 4 times, 5 number will comes to higher nibble position. Maybe after a rotation S value becomes 54. So at first you have sent 4 number by using D4 to D7 data lines. Later by rotating left for 4 times, then lower nibble comes to higher nibble position. After that you can send higher after that you can send this, data. It is a simple concept, right? Now this is the important to understand, and later in the coding part, in the programming section, initialize just define port 2.0 is connecting to the RS, 2.1 connecting to the enable line, port 3 is connected to the LCD. So LCD means 4 data lines or 8 data lines I am configuring. After that, initialization of LCD. So first I am sending 02 command, which is used to initialize LCD in 4-bit mode. Okay, a call rotate. So don't forget the concept. When you are sending data as well as command, we should send higher nibble first using D4 to data lines, D4 to D7 data lines. After that, rotate the character to the left 4 times, and after that we can send rotational value. That was the concept. That's why I'm taking command number into the A register. Later I'm calling subprogram as a rotate. Somewhere you have a subprogram as rotate. This is the rotate. A call command. Here I'm sending higher nibble first. This is the subprogram to send higher nibble. After that return the previous one. This is the previous one. Here you can see that I'm rotating content of A to the left for 4 times. It is one of the approach. Okay, so after rotating the data for 4 times, again I'm calling the command a call command subprogram. Again I'm sending lower nibble. Now it will present at the higher nibble position. Now I'm sending this data. Okay, so likewise you can send all commands in the same format, which are the required commands. 02 for configure LCD in the 4-bit format, and later 06 for increment the cursor position, 0C command for display on cursor off, 80 command is used to target first row first column so that you can display from first row first column onwards, 01 command to clear previous state on LCD module. Okay, and after that our mode is send the data. So in my example I have a text from 1000 onwards. I'm taking that address into the data pointer register. After that I'm getting the values. Okay, uh, to identify the end of the string you are taking 0. Let me show that. Yeah, so from 1000 onwards I have a data. Okay, suppose it is my content. At the define our string within the double quotes comma 00h. This is the 00h number will define your end of the string. So you are picking the character as a one by one, letter by letter. So after getting character by character at the end you are fetching 0 number. So in that process, once if we get the 0, which indicates that it is a end of the string. So by using this command, this one, I'm trying to get the values. So after getting the characters, I'm checking if it is 0, just you jump to the exit point. If not, a call send 1. Let us see what we have in that. A call send 1. Yes, a call send. Yes, in the a call send again, we have to send respect to ask a value for 2 times. Higher nibble first, and after that higher nibble first. After that rotate existing character for the 4 times to the left. After completion of that, send the data same. A call send. We have another subprogram for that. A call send. So how you're operating RS, enable and so on, everything clearly explained in the previous video. So I will add in the description. Please check out. Okay, already I just written the code. I have verified that. Okay, you know how to create the project and also how to generate the X file. Okay, let me run the code. You can observe. So just we have to use higher data lines D4 to D7. Don't use lower data lines D0, D1, D2, D3. Don't use lower order data lines. We should use higher order data lines from D4, D5, D6, D7, which are connected to port 3 higher order IO lines. Port 3.4, 3.5, 3.6 and 3.7. Okay, so this is the 4-bit connection. After that upload our X file and now you can run the circuit. Just wait a minute. Yeah, robotic inverts, it's our channel name actually. So in that way you can interface 4-bit LCD. If you have any doubts you can comment in the section. Thank you.